Yeah, thanks for having us. My name is Daniel. I lead the platform engineering team at Springer Nature. That's my colleague.
Yeah, I'm Simon. I'm a platform engineer in Daniel's team.
So yeah, this is the talk we gave at the CF Summit in Berlin. So let's start. So we work at Springer Nature. It's a large global publisher. We have offices all around the world, around 13,000 employees, and hundreds of developers in various countries. We have some fairly large online platforms, SpringerLink, nature.com, biometcentral.com, maybe you've heard of those, or maybe not. But the story is quite generic, so it's not about publishing or anything like that. So it applies to all sorts of businesses.
Indeed. And this is basically our story, how we prevented 1,200 applications turning into 1,200 snowflakes, and how we took deployment basically from weeks to minutes.
Yeah. So let's take a step back in time. The story begins when Springer decided to bring in one of its major online platforms, SpringerLink. At that time it was hosted and completely operated by a third party. Bringing it in meant bringing in all the development, but also the operations and support. It was quite a successful platform at that time already, so millions of users every day.
Yeah, and we decided to do it right from the start this time around, like do it the whole agile train. And it was really a great success. People loved it. It was a great code base, and customers loved it. It was easy to use. And yeah, it was a great success basically. And so a lot of other new projects started popping up once the management realized that we can do this in-house. And that's great, right? So now we have lots of movement in the company, but the ops organization of the business has not gone through the agile transformation at this stage. So we were kind of, drowning, I would say.
Yeah, so yeah, to give you a better idea of what it was like back then, to go from an idea to production, I would like to run you through a little scenario. So yeah, where would you normally start, Simon?
Guess I will write some code.
Write some code. Yeah, you need anything else? Or?
Guess we need a VM to run the code on.
Yeah, so request a VM, nice. And then?
Request DNS.
DNS, sure. Anything else?
NFS, like we need to store random stuff somewhere.
Okay, that sounds ugly, but okay. Pretty sure it's necessary then. Good to go, or?
Kinda, it turns out NFS, or my VM cannot talk to NFS, so we talked to network team and requested firewall changes.
Okay, but then it's done, right?
Kinda, we just need to request a public IP so someone can actually reach the application.
That sounds like a terrible mess, but now, okay, or?
Yeah, just DNS for the public IP as well.
Okay.
Yes.
And how did you set this up all manually, or?
Yeah, I mean, who has the time for configuration management until now, right? So let's just invest some time in that.
Okay, maybe some chef scripts, sounds good. And then, good?
Yeah, I mean, we're live now, but we have no redundancies, so we're gonna request another VM.
Okay, more. Do we have enough hardware for more VMs, or?
Most likely not, right?
So crap. So we need to order more hardware, which is gonna take weeks probably to arrive. That sounds like madness. So yeah, that was not working very well. If we would continue like that, we would end up like this probably. And on top of that, it had a lot of consequences. So we saw a lot of silos arise in the company because people would try to work around all this madness. So they started building all local optimizations. They started building their own monitoring system. So we got iSyngas everywhere, Graphite servers. Teams were using Chef, and we had Chef overriding Puppet, and it was a fun time. And it resulted in a lot of unreliable services in the end. So yeah, we were a bit like this. So what to do? At that time I started traveling to all of these locations where the local teams were optimizing their systems. And I met all these ops people. I met Simon, he was in London at the time, working in the local DevOps team. And I thought, okay, these people are actually quite smart, and maybe if we bring them together, start thinking more globally, we can fix this mess and create, duplicate systems and create a global solutions. And yeah, that's what we did. So we started a new team, global platform engineering team, lots of smart people. We will be the heroes in town, fix all the problems, and make everything go faster.
Yeah, right. So we want to build a really scalable and awesome infrastructure. We want to build a $6 billion infrastructure, basically.
Yeah.
So short recap. We went from outsourced everything to bringing some development in-house. Super cool. Unfortunately, it resulted in lots of local optimization and silos due to us ops people not being up to par, basically. But platform engineering was formed, so we got that going for us.
So that's sweet. But now what? So, well, no worries. Platform engineering got you back. We know what to do. We know what the people need. So, arranged the team meeting in Berlin. We got all the platform engineers together. We locked ourselves in a cave for 3 days, made a list of all the problems we knew that were in the business, and came up with all the solutions. That worked pretty well, right?
Yeah, I think so. As Daniel said, we were all from different kind of ops silos within the company, so we knew where the pain points were, both for us as operations people and for the developers as developers, I guess. So we went into the cave and tried to figure out what do we need to do next, and we came up with the answer. Faster horses, right?
Horses, clearly.
Clearly. So, I mean, it's bullshit that we have to wait days for a VM when we should have one in minutes, right? DNS changes, we should be able to change that ourselves. We need flashy configuration management. That's just super awesome. Shared services. I mean, there's no reason to have 5 Icinga instances in a company, maybe.
Oh.
So, yeah, just fix that.
Yeah, we started doing that, right? And it went pretty well.
Yeah, I think so.
So, but then, yeah, someone started talking about microservices. And yeah, we were in a bit of trouble again. Because yeah, we could have probably continued with 10, maybe 15 monoliths and do everything with this configuration management and all that shiny things. But if you multiply that by 100, 200, 300 little services per monolith maybe, we were clearly going in the wrong direction. We wouldn't be able to scale our systems. So we needed to go back and rethink our strategy. And this time we learned from our mistakes and we
I decided to listen to what people actually want instead of enforcing our own cool operational views on people, I guess. In retrospect, it was really easy, actually, the answer to our question, what do you want, what do you need from the platform you're going to deploy it to? And just run code, right? For me, it's super interesting with servers and containers and, I don't know, load balancers and shiny configuration management. Most of the time, though, we found out the developers don't really care about that stuff at all. They just want to run their code. Be able to provide business value as quickly as possible. So we basically said, you want a private pass? And they were saying,
yeah.
Yes.
And that's...
It's the knight in the shining armor here, Cloud Foundry. So we started spiking different solutions that was available at the time. So we had Cloud Foundry, obviously, OpenShift from Red Hat, Daze and Flynn and all the cool Docker-based ones. But it was pretty clear from the get-go that the only viable option was Cloud Foundry. To start with, we had a huge investment in our own data centers. But we had no automation, right? We still had to send emails. Even us in the ops team had to send emails to other teams to get a VM, or to change a DNS entry, or configure load balancers. So we couldn't use many of the tools because of this. Also the fact that we had our really large investment in data centers made how to explain this, but developers made choices, right, in the architecture that required sub-millisecond latency to application, complex business logic, integration with SAP and other back office boring stuff. Sorry, if there's an SAP people in the house. Yeah, so that pretty much ruled out anything that we couldn't run on-prem in our quite static environment at the moment. Luckily, Cloud Foundry has an ace up its sleeve, right, and it's Bosch. With Bosch, we could actually deploy Cloud Foundry on the actual hardware in an actual data center where the actual application would be running, because we were not going to be able to go to the cloud.
Yeah.
And
So we
cool.
were pretty confident, right? You did a lot of that research, and we were pretty confident that Cloud Foundry was the way forward. So we were ready to go to the next step, We created, we did a small presentation and a business case. Everyone was convinced, so we were able to invest some money, bought some real hardware, wrecked it in the data centers, together with the ops team, and we were really excited, and it was fantastic. I mean, right? The platform was fantastic, but it was empty. I mean, no one was using it. Basically, we've built a nice, shiny dust collector. The problem was that, at least I think the problem was that people didn't have trust in this new thing. Is it production ready? How do I use it? They had no knowledge, no experience with this whole cloud native stuff. So, and on top of that, there's business as usual. Developers need to deliver features to the business, and they should not work on tech tasks because that's a waste of time. And unfortunately, you do need to invest a little bit of time on your code to make it run in the platform.
Legacy code.
Legacy code, yeah, everything is legacy. So, yeah, so that was a bit of a problem, and so we needed to do something, and we entered the sales mode, basically.
Indeed. So we started to sell the platform pretty aggressively. Internally in our team, we were using it for all sorts of stuff, our dashboards, our APIs that we exposed to people. But we wanted other people to use it, not just us. So we started recording videos, sending them around through the company. We started using subliminal messaging. So we would get a request and we would say, yeah, sure, we can help you. But do you know about Cloud Foundry in the corner? It's really, really cool. And at some point we got fed up with it all and just said, no, we're not going to help you. You can use Cloud Foundry for your dashboard. And it worked, actually. People started to use and rely on Cloud Foundry for non-business critical stuff. So,
yeah,
success.
small things, dashboards, little things, but still not much. But then microservices came back to the table. And the second time around, we were pretty happy with it because we were ready. We had this nice platform which is built for microservices architecture. So at the same time, they decided to rebuild a very large open access platform, completely on a microservice architecture. Together with the developers, we agreed to use Cloud Foundry from day zero. And that was the best decision, I think, because they immediately saw the benefits, and they had greenfield, so they got so much benefits, fast feedback, everything, that the people around them also started seeing the benefits. And basically, people got inspired and started looking at their current existing code and started peeling off little bits and pieces and started pushing those little things into Cloud Foundry. And yeah, we finally got traction then. So yeah, a short recap. So we started with the faster horses, which was a bad idea because we should have listened first. So when we started listening, we understood that the developers were interested in running their code and getting fast feedback. So Cloud Foundry enters the picture. But then we had no usage, so we started selling the platform, and then we got to the initial adoption, which is good, but not yet great.
Yeah, so cool. We have this amazing platform that people can use. But at this time, actually, we were sort of creating problems for ourselves. It was now quicker than ever to push Snowflakes in production, which was really scary. So what we noticed was that every single team that started to use Cloud Foundry started to build their own automation around the platform, their own pipelines, their own way of doing zero downtime deployments, etc., etc. So we needed to fix that in some way.
Yeah.
And we did. So we have something that we call the Springer App Anatomy, which is basically, it came about by having all the tech leads that were using Cloud Foundry in their teams to discuss how they were using the platform, what patterns they were using, etc., etc. And we came up with this. It's loosely based around the 12-factor app, but we added some of our own goodies in there.
Yeah, on top of that, we have this.
Yeah, we have the automated pipelines, which is pretty cool, I have to say. So yeah, now we have like a runtime, we have a way of developing against it, but CI was still something that was kind of handcrafted over the, we had some servers sitting there in the corner that's been running for years and people logging in and doing manual changes, and it was an awful mess. So one team was formed called Tools Engineering that took upon themselves to kind of generalize CI in the company. And they have been able to do that using GoCI. So right now we have execution platform generalized across the company. We have a way of developing across the company, and a way of deploying and running your test across the company is exactly the same, regardless where in the world you are, what team, etc., etc.
Which is nice.
And we also built some candy. So we started out with working with Varnish for internal caching layer. So that's fully transparent to the developer. They just have to make sure to either request with the correct headers or respond with the correct headers, and the kind of Varnish layer takes care of it all. We then expanded this to also work with Fastly and Akamai out there, somewhere else outside the data center. So it's the same way of doing things, which is pretty cool, I would say. What else did we do?
Monitoring for
Monitoring.
free.
So Springer App Anatomy has a clause where it states that your application must expose a certain endpoint. If it doesn't, it won't be deployed into live. And that nifty little endpoint specifies how your application should be monitored, who you should contact in case of failure, stuff like this. So you get free monitoring from the platform, which is super nice. Dashboard, stats, all that kind of stuff we can auto-generate because everything is API-driven in Cloud Foundry, so it makes it really, really simple to do cool stuff.
Yeah. So that kind of brings us to where we are today. And it's safe to say that Cloud Foundry is now the preferred way of deploying software in our company, which is really cool. And we just want to give you an impression of what the platform is handling at the moment. So we have a few facts and figures for you. We had to change these facts and figures because it's grown a lot since Berlin. So we do around 700 deployments around the clock. And I think about 200-300 of those go straight into production, fully automated. We have 1,200 running apps. And the platform handles 4,000 requests per second, and that is constantly, dev and live combined. And all of this traffic is global. We serve traffic from every country in the world, including North Korea. What's also a good point, I heard other people talk about this as well, is the footprint. It's really small if you compare it to where we come from. It's just a couple of physical servers in two data centers for HA. And it's maintained by a few people in our team, so it's not big. You can get a better impression maybe if you look at this.
Yeah, I won't read out the numbers, but as you can see, it's pretty much in favor of that side, isn't it? The real benefit though with Cloud Foundry, I think, is not the fact that we can remove some VMs here and there. It's the fact that we have this lovely, lovely generalization with the build packs. So should we have gone down this road, we would have to have written some really nasty chef stuff to be able to handle all the frameworks, all the libraries, all the different languages people want to use. Cloud Foundry, we don't care, to be honest, right? Developers needs to run something and they run it themselves, and we don't have to do anything to make it so, right? It's lovely. Another cool thing with Cloud Foundry, or Bosch again, is the fact that it's so amazingly amazing. So when I'm sure you all remember Shell Shock, right? Cloud Foundry, we patched our environment in a matter of hours. It was no big deal, seriously. But we, of course, as an old organization, have a ton of old servers, and that just took so much time and effort to patch those servers because nobody knew anything about them. Cloud Foundry is all awesome and nice and repeatable and automated, so it doesn't matter if something happened, we just fix it. Super cool.
And for these reasons also, we are able to stay always up to date with the latest releases of CF.
Yeah, we're always on the
upgrade
latest.
every 2 weeks, and no one noticed. So it's really nice. Another cool thing is that I think it's remarkable for a company like Springer Nature. We use the community version of Cloud Foundry, completely open source. So all our mission critical business applications, customer facing, run on community open source software. It's a great community to be in. It has a lot of benefits. We also try to give a little bit back. Yeah, you can tell more about that.
Sure. Yeah, a large part is, as you say, it's a community edition, and it's actually a community edition of Cloud Foundry. I mean, development is open. The pivotal tracker for the project is open. The mailing list are open. The Slack, everything is open with Cloud Foundry, which is super awesome. Which allows us to look at the code, help to contribute back, develop stuff around it, and yeah, it's a really nice place to be in as a project.
And we have open sourced some little projects as well, right?
Yeah,
syslog, Firehost to syslog.
Firehost to syslog, which takes all the messages in Cloud Foundry and forwards it to a syslog host somewhere. It's pretty cool. We do a couple of 100 million events a day with that, so it's pretty production ready. We have the glue that we have between Cloud Foundry and the monitoring system, fully open source. It's on the Springer PE GitHub account, I think. Yeah. Dashboards, small APIs around it.
Yeah, light API.
Yeah.
Yeah. So it's been quite a cool journey so far. It's far from over, but it's been really good. We made a lot of mistakes. We learned a lot. I'm not going to share all the mistakes with you today. Then we will be here too long. So, but the most important thing, I think, is this stuff can be done in enterprise organizations. You can change the way you work, change the way the ops and devs work together, introduce community software, and have business applications, critical applications running on top of that. Yeah, as long as you remember to involve everyone from the beginning. Don't go in the cave and think you know the answers to all the problems, because you're going to be horribly wrong. It's important to, I think, build trust first, then start building the system. Otherwise, you end up with the crickets in the corner, no usage. And if you get all that stuff right, I think you can go from...
Yeah, like horrible big monoliths with one deploy a week if you're lucky, right? Lots of local optimization and snowflakes and horribleness all around. To something suitable for 2016. We have lots of apps that gets deployed all the time. Lots of global standards in place, so it again doesn't matter what team you're on or rolling on and off teams. It's just going to be the same for you to do what you need to do, which is great. And all of this was made in a kind of grassroots movement in collaboration with developers. So it wasn't something that was forced upon us from the ups.
So yeah, to give you a little bit of an idea of what it's like today to go from an idea to production, where would you start?
Write some code.
Nice. And then you request a VM, or?
You just type CF push.
Oh, cool. I probably need some DNS somewhere for my app to be accessible.
No, that's handled by the guru routers. It's all cool.
Nice, nice. Need some NFS storage maybe for my state in my app?
No, we realized that NFS is actually a very terrible thing, so we stopped caring about that stuff.
Okay, cool, stateless. But do certainly need to open up a firewall, right, to get to my app?
No, since it's all nice and self-contained and it's very easy to work around, we can kind of create generic firewall rules so we don't have to open stuff randomly.
So you have a lot of chef scripts in place, configuration management to handle all of this, or?
Not a single line.
Not a single line, I like that. But then I certainly need to go to the network team for my public IP to get access to my applications for my customer.
No, you just bind a domain to your app and your public.
I can do that myself?
Yeah, for sure.
Cool. But if I'm live and I decide that I need to scale because I maybe need more VMs or...
CF scale.
Cool, cool. And then I need to load balance all the traffic in the load balancing F5 device somewhere. Network team again, or?
I mean, yeah, you need to load balance, but that's all taken care of by the platform itself. So
cool. Wow, that's pretty badass. I would say. So yeah, that's our story so far. I want to thank my wife for the slides. She made all the slides. We made them at home. So big shout out and thanks for listening.
Thank you.